my first class. Okay, and first of all, congratulations to most of you. I believe that all of you have scored the previous semester final assessment. Okay, I think most of you get a very good grade. And that is the only good things of COVID-19, I believe. Am I right? Yes, give some response to me. And it's a bit weird to talk in front of the camera. So I would be happy if few of you dare to switch on your camera as well. Okay. Okay, no one willing to switch on their camera. Okay. So, as usual, this is a Utah requirement. So we still have to go through all this definition of PO, PO, and CO. I believe most of you are quite familiar with all of this, but this is the rules. I'm being assigned to briefly go through, this PO, PO, and CO. So I believe most of you know what is a PO. PO is a program education objectives. Okay, hold on first. I want to make a recording. Okay, let me record it. Come back to this. Start. Okay. Okay, so PO basically is a program education objective. Okay, so which address the graduate attainment within the 3 to 5 years after you are graduated. Okay, whereas PO is a program outcome. By the time you graduated, you already achieved these program outcomes, our university programs outcomes. So addressing cognitive, psychomotor, affective. Okay. So whereas course outcome is described, the students are expected to know and be able to perform after the completion of this course. Means after you complete this embedded system design, you definitely, or I hope that you meet all the course outcome. Okay. So what is a PO? So this is a 3 PO of 3E. Okay. This is an example. So for Megatronic, probably your PO might be different. Okay. So basically, the PO1 is a graduate competent in practicing fundamental scientific and engineering principles in electrical and electronic industry in a creative and innovative manner. So it means that you are more creative and innovative upon graduating, upon you are graduated from 3E. So PO2 is a graduate are capable to communicating and managing effectively in diverse areas of electrical and electronic engineering. And finally, graduate are practicing professional ethics, lifelong learning, and sustainable development and betterment of the profession and society. Okay. So, and whereas we have about 12 PO, you can briefly go through it. I believe most of you already quite expert because I believe that most of the lecture already delivered this slide to all of you. So I'm not going through in details. Okay. So, and we're also doing a mapping from a PO to PO. To each subject, we are doing a mapping from program outcome to program PO. Okay, here are some of the example. And then whereas we have a course outcome, we go through, let's go through the embedded system design course outcome for this semester. Okay, hold on first. Let me open the slides. Okay, for embedded system design, okay, the course outcome is we evaluate the embedded system life cycle. So this means that at the end of this course, you're able to start designing, okay, from the beginning till the end. Okay. So secondly, you're creating embedded system design using a design tools and integrated development environment. So this means that, for example, I give you ESP32, you're able to program the ESP32 using Arduino or other development tools. Like if you're using microchip, you're able to using the microchip IDE to program the microchip microcontroller. So for the course outcome tree, you're able to illustrate the importance of RTOS. You just illustrate. So you must understand why real-time operating system is so important in embedded system design. So finally, you're able to construct and test an embedded system design. You're able to design scratch from, I give you a components, you're able to design one embedded system, project, based on the specification given to you, and you're able to test it, you're able to debug it. So this basically is the 4 COs of this semester of this subject. Back to, okay. So basically, we map the CO to PO as well. Okay, so ensure that you achieve, the appropriate PO with the CO that we have met. Okay, finally, the assessment to the CO. So the CO are assessed through practical, midterm, and now it's a final assessment. Okay. So then finally, each of you will receive this this beautiful chart. What is the score of each CO? Okay, and this one you can get it from your own advisor. Okay, so here is some example of individual PO achievement. Okay, so how many points you have scored, Okay, basically a 12 PO. So we can identify your weakness and strength, based on your all these results mapping. Okay, I think that's all for the OBE briefing. So is it okay? If okay, can you please raise your hand? At least raise your hand. Okay, great. How many of you actually? Why Dan Junhao want to control my slide, is it? Okay, you can, okay, let's move on to our subject, UEA 4663. Okay, so welcome to UEA 4663 Embedded System Design. Okay, so here is my emails. Okay, you can send emails to me through my personal email and my Utah email. Okay, and you are advised, you're encouraged to join the Facebook group. If you're joined, good. I already uploaded a few videos there. So if you're not, please do so. Okay. If you feel shy, to give me to ask question, you can always post your question to Slido. Okay, because Slido don't have your name. Okay. So the event code is 8106. It's very simple. You just go to this website and key in 85106, and then you can post your questions already. Okay, and no one know who you are. Okay, that's very important. Am I right? Okay, and of course, this Slido is just lasts for 1 week. So each week I will give you a new code. Okay, I will answer all the questions posted in Slido. Okay. Okay. So the course introduction. Okay, this is my name. I believe most of you already quite familiar with me, and my office is G41. Right now, of course, I'm not in the office, but however, I'm being assigned go back to Utah every Tuesday. So if you want to meet me, so just give me drop me an email or message. Okay. So, but I can be reached by my FB Messenger and WhatsApp. Okay. So as usual, 3 hours per week, and tutorial. I try, because we just have 4 tutorial classes based on our teaching plan. Okay. So I try to convert the tutorial to lecture section if there's no crashes with other classes. Okay, I will let you know. So, and we have a lab, and the lab is basically on project and a lot of assignment. Okay, so the mark allocation, the final assessment is 40. It's no longer 30, like last semester is 40, and the coursework is 60. Okay, so lab assignment normally will take about 10. Lab assignment 2, another 10. Okay, remember all these are individual assignment, and the final man assignment is 30. So, and then we have a 1 midterm. So midterm is somewhere near week 7, 8, and 9. Okay, so it's total up to be 60. Contribute 60 to the coursework. Okay, so is it clear? Okay, let's move on. So here are our timetable, and here are my consultation hour from 8 to 10. So, but anyway, you can contact me anytime as you like, except midnight. Okay. So this is my lecture hour. I hope this is agreeable to what you have in your at your site. Okay. I hope you also receive the same timetable as me. Okay. Tuesday is my consultation hour as well, 10 to 12. Okay. And then Thursday is we have a lab. Okay. So far we have a lab P2 group and P3 group. Okay. So class, remember, although the lab section will start at week 3, 4, 7, 8, 11, 12. Okay. Next week, I try to start lab section for all of you. Okay, so that I need to ensure that all the necessary tools have been installed properly into your system. So next Thursday, is it okay to have a lab section from 9 to 12? Okay, if you're not able to make it, please drop me a message. Okay, I hope all of you are able to make it. Okay, from 9 to 12. Okay, so you will start our tutorial next week. If okay, next week. Okay, we'll only start our tutorial 1, 2, 3, 4. Okay, we only start our tutorial at week 6. I try to have a lecture section in week 2, 3, 4, 5, if possible. Okay, just let me know again if you are not possible. Okay, I repeat, we will start our lab section, a pre-lab section next week. I just want to ensure that everyone, install a proper component, okay, into your system. So whereas for week 2, week 3, week 4, week 5, or probably just week 2 and week 3 first, okay, we try to convert this to as our lecture section. So they have 2 lecture section back to back. It only happen if you don't have any other classes. Okay, is it all right? Okay, just drop me a message if you're not able to make it. Even one of you not able to make it, we don't have any lecture, in week 2 or week 3 or week 4 or week 5. But however, our tutorial will start at week 6 because we only have 4 tutorials. Okay, is it all right? Okay, so let's move on. So then followed by lectures from 5 to 6. So we check our timetable. So here is some of my info. So currently I'm doing something on visible light communication, IoT, and face recognitions. So we just move on. Okay, so coursework. Okay, this one. So I will give you a test at appropriate time. Okay, so 10 marks as I told you just now. So, and then we are using 2 real-time operating system. We try to type micro COS2 with microchip. Okay, class, remember, microchip also support FreeRTOS. I just try, 2 different real-time operating system. Micro COS2 type with microchip. FreeRTOS we type with ESP32. Okay, so what is ESP32? We know more. I will discuss more details with you later. So then we are using MPLAB with XC16C compiler. Okay, you are encouraged to install XC8 as well because our lab section 1 we start with XC8. Okay, then we move to XC16. We have Proteus, CowU Vision, and we will perform a lot of virtual simulation because we don't have lab, we do not have expensive oscilloscope. I believe that you do not have a oscilloscope with you. Okay, unless you are able to get yourself a PC-based oscilloscope. Okay, but okay, that's not important. But I believe that all of you at least have a multimeter with you. So PM me if you do not have a multimeter. Okay, so we perform a lot of software simulation. Okay, on PIC24. So if you're using PIC24, you no need to do hardware connection, hardware construction. Okay. And then same, I will touch a bit of an Intel MCS51 family microcontroller. Okay, this is an 8-bit microcontroller. Okay, I'm using a software called CowU Vision. Okay, so and then STM32 Cortex ARM, I tentatively remove it this semester because it's quite heavy for all of you, and I replaced by ESP32. Is easier, compared to STM32 Cortex ARM. Okay, so I hope that hope that you own yourself a development board, ESP32 development board. Okay, we go details later. Okay, so and then we also touch about PIC24. We use most of the experiment using PIC24 and ESP32. Okay, good. Okay, so this is a component I propose for you to purchase. Okay, so class, actually all these component is available in the lab. Those is in the Klang Valley. If you don't want to purchase, actually you can loan it, from our Utah Songai Long campus. Okay, to let me know if you want to loan it. But however, I already do some investigation online by going through Shopee. They got 2 shops from Penang, STE Electronics or Little Craft. So all of these component, ESP32 Do-It Kit is similar to not MCU ESP32, and the DHT11 temperature and humidity sensor, a few push button, a few LED with a breakboard and mail jumper wire, blah blah blah. So all this is cost less than 50 ringgit only. Okay, so I believe that if you start ordering now, you will receive it within 1 to 2 weeks. Okay, I think should be within 1 week because it's from Penang. It will be less than 30 ringgit, if this is purchased overseas from China. But of course, China takes some time to reach your doorstep. Okay, so I'm not sure. Probably get it cheaper from Lazada or other company. You can have a look. Do let me know if you get somewhere cheaper so that I can bookmark the respective seller. Okay. So here are some of the references I recommend to you. Class, this is just a references. Okay, and all these references is all these books, reference book is quite expensive. Okay, like CMP, all these things is very expensive. It costs more than 200-300 ringgit. I believe that nowadays you are better than me. You don't need hard copy. I believe you can get a free copy, online. Okay, class, this is just a recommendation. So other related books is perfectly all right. Okay, like for example, MicroCOS2 by Sean Labros is free. Okay, it's free. You can get it from the respective website. And for example, ESP32, you can get a lot of free books, from the website. Okay, from a different website. Okay, so let's move on. Okay, so the red color one is the books that I recommended. However, if you're good, just rely on online articles. Datasheet will do. Actually, you do not need all these. Okay, datasheet, online articles will do. But if you need an example, okay, step-by-step guidance. So these 3 books are these 2 books are recommended. Okay, let's move on. So here are some of the books that I recommended. So this is not bad. This is quite easy to understand. Okay. So here are some of the expectation of this subject. So most of you are already in 4th year, final year, or some of you already in year 3, SEM 2 or SEM 3. So as you know that embedded system design involves a lot of hardware, but due to the COVID-19, so the hardware definitely is very difficult to be implemented. So, but for previous student, your senior, I do expect they know how to draw PCB. They know how to draw, look at schematic diagram. They know what is system on chip, what is networking, fundamental of networking. They know what is memory interfacing. They know what is data bus, what is address bus. Okay, how we have a program code memory, we got data memory. Okay, so you also must understand ASIC design. Okay, application specific integrated circuit. So ASIC design is to design a unique type of processor or microcontroller for a specific application. Okay, not the mass production type of IC. Okay, so and some of the FPGA field programmer get array. Okay, like you must know what is Xilinx, Altera. Okay, I'm not sure whether you went through this or not. Okay, but however, this is some of my expectation. Okay, it will be good if you know this. It's fine. It's perfectly all right if you don't know this. Okay, so FPGA normally we are using Verilog or VHDL language. This is a very popular language. I'm not sure whether you learned is it the Verilog and VHDL. Okay, so I believe that some of the subject to use Verilog and VHDL for 3E. I'm not sure which subject. Okay, and then you must know all the analog components. You must know how to deal with LED, push button, keypad, and different type of sensor, okay, and you must know all the digital things, some fundamental of analog digital converter, which you have learned, in microcontroller and microprocessor, okay. So, and I believe that you learn quite a lot from the subject microcontroller and microprocessor, which is a prerequisite of this subject, okay. But don't worry, I will do a revision, but it's fast, okay, but those days I'm going very fast, but of course now it's recorded. I will go quite slow. Okay, I will point the right direction, but you have to get it there. So you have to work hard. You have to, even though I give you all the material, you still need to spend a bit of time to go through all the material. Okay, so and you are expected to really understand data sheets. Okay, I believe most of you have went through industrial training. So when you go to industrial training, the first week, even though in future you get a engineer position in Intel, the first month, you are just reading manuals and data sheets. Okay, so you have to familiarize, the technique of reading data sheets and manuals. Okay, so discussion is good. You're always welcome. Like today, I'm talking about 120 minutes. My throat already a bit dry. Okay, so I think it's good, I will call your name, you just switch on your video, okay, your camera, so I see who you are. You see quite a number of you there here, so I don't know who you are, how you looks like, until the end of this semester. So at least I know who you are, how you look like, okay. So discussion is good. Probably you know something I don't know. Okay, nowadays embedded system design is already evolving. There's a lot of material online. You're encouraged to go through different type of website, different type of webinar, all these things, so to enhance your knowledge. So something that you don't know, probably I know. Something that I know, probably I don't know. Okay, probably I know, you don't know, probably you know I don't know. Okay, so I make mistakes, so it's good, for you to discuss with me. So you can ask question anytime through Slido. They got a code given to you. You can try it now. And you can raise your hand in Microsoft Teams. Let me check, because I switch on to two terminals. Okay. Okay. So there's questions by this Lauman Singh. He asks, may I ask, main assignment is group or individual? Okay. Because due to COVID-19, individual is always recommended. Maximum is 2 persons. If some of you, think that you are quite weak, you need someone to assist you. So therefore, just make it 2. Okay, is it all right? Okay, so if you're confused, either confused too, please ask questions. Okay, let me know if I'm talking too fast. And I put a star here. It would be good if you've got 2 terminals. 2 terminals means that, let's say lab, I give you a step-by-step guidance how to put a debugging point. While you watching the video, it will be good you have another terminal with you, to install with all the dedicated software to do it at the real time. Probably you can use your, I don't know, probably use your mobile phone and as one terminal, and your laptop, is where you play around with all the IDE software, okay, in real time. This is what I recommended to you, correct? So it's a bit hard, if I'm like example, I switch on my MP Lab here, I'm doing step by step, and you're just watching, correct? Okay, even though it's recorded, some of you are lazy to watch, to repeat and watch the video again. Okay, so let's move on. Okay, so first of all, actually, your senior also don't have an ARM development board. Okay, so actually we do not have any development board. So your senior is always asked, to get the microcontroller PIC24 16-bit microcontroller, the PIC24 FJ64GS002. Okay, so and construct it, okay, and build their own development board. Okay, I can say that. Okay, but however, if you purchase a ESP32 DOIT development board, you already have your own development board. Okay, so and we still stick with PIC24. Okay, but however, start from next semester, actually, I already proposed to purchase a development board using PIC24. I will let you know later. Let's move on first. Okay, I cross ESP32 because things is evolving. You stick with ESP32. It's more better. We use this as a IoT devices. Okay, so the syllabus is very ambitious. Like real-time operating system, we cover it within less than few hours. That is not possible. But I try my best, to just dig out the important sections, to let you all know. So the remaining you have to explore yourself. Okay, so lab section is unlimited, but however, I give more lab sections. If the class is, if you don't have no crashes, within with other subject. Okay, so so I try, that's why we don't have enough time, and then moreover, lab section have to sync with the lecturer. So lab 1 is started in week 3. So therefore, that's the reason I try to use tutorial and convert become lecture, so that we can catch up with the lab section. Okay, only 4 sections in real tutorial. And remember, I will jump here and there. You will get confused. You have to get used to my style. Why I jump here and there? So I always jump to the data sheet. SM microchip data sheet. I will jump to the data sheet, look at the data sheet specifications to let you know. So that's why you can see a lot of jumping here and there. Okay, there's a lot of data sheets. Okay, you need to familiar with all the data sheets. And my lecture note, you can see, is touching 130 pages. Okay, because I already dig out all the summary to you. I notice most of you don't like to read. That is the main problem of you guys nowadays. Okay, okay, I will. So that's why I asked you to have 2 terminal. So class, this is the one we're going to use next semester, next year. Okay, we are no longer using PIC24, and then we're no longer using ESP32. We directly migrate to this IoT-based microchip development board. It's very interesting. Okay, and I already purchased a lot of different kind of sensor, including LoRa sensor. So, but this is not this semester. This round is next year. Okay, okay. So here are some of the software you need to download. Okay, but of course, for your information, personally, I don't like MP Lab because MP Lab is very slow. It takes a lot of my computer resources because it's a Java base. Okay, so if you are encountering problem of slow, very slow, you can go back to the old version of MP Lab IDE. Of course, the older version, the layout is totally is totally different. Okay, of course the GUI looks nicer. If you go to MPLAB X, okay, you are asked to install MPLAB X. You have to install the XC8 and XC16 compiler. Okay, so this is a C compiler. Okay, and remember, start from now, everything is using C programming. You're no longer touching assembly code. Okay, assembly code is for your microcontroller and microprocessor. And you can go to the PIC24 FJ and download the application notes. There are a lot of documents over here. Okay, if you're able to understand all of this, means you are already an expert, even better than me for this microcontroller. Okay. So and then we also have a CalView Vision. Okay, we are using CalView Vision. CalView Vision is IDE, started in Germany in 1982. This is my baby, one of my favorite development IDE development tools. Okay, so you can support all the MCS51 family, as well as all the ARM microcontroller that is very popular nowadays. All ARM microcontroller, whether it's an STM ARM or Hitachi ARM. So remember, it can be compiled, by CalView Vision. So you can download it. It's free. Okay, but of course they got some limitation. Okay, it's just the code size, but the code size is enough for all of you as a student. Okay, please download and install. I don't think so you face any problem when you're installing CalView Vision, but you might encounter a bit of problem in installing MPLAB X and C compiler. Okay, then we are using Proteus. Why we're using Proteus? Proteus is a simulation software. Okay, because you don't have the you are no longer asked to construct the hardware. So that's why we are using Proteus to do all the simulation. Okay, but however, the Proteus, that you downloaded in this website is just a demo copy. Okay, I believe that all of you are already expert. You can get a better version or full version for yourself. Okay, you know what I mean, correct? And of course, please download the latest version of Arduino IDE, because we are going to use ESP32. Okay. Why is not moving? Okay. So if you got enough time, we might look into the IBM Cloud MQTT. But again, if time is allowed, because this subject is there's a lot of things in this subject. Okay. So and then we look into Node-RED. Okay. Node-RED is a flowchart base of programming. Is very easy. Okay, all my students love it. Okay, all my FIP students love it. Okay, because it's quite straightforward and easy. And then we look into the Firebase. Okay, and IFTTT. Some of the cloud supplier like ThinkSpeed, Carriot, and Tamboo. All these things you just touch and go if you got enough time. Okay. So, however, you also can download the MLA, microchip library for applications. So this means that if you realize that nowadays, like embedded devices like ESP32, they already come with lots of library. Okay, when there's a library, it makes the developer easy life. Okay. So that's why a lot of students, correct? Even you guys like Arduino so much, Uno, all these things. Why? Because there's a lot of library. You don't need to do a lot of things, a lot of programming. You just call the library. But however, if you're using microchip PIC24, they don't have much library for all of you. You need to write it. Okay, you have to develop your own library, basically your own driver. Okay, so this is what I want you to learn, to develop your own simple driver. But however, like driver like USB is not possible to be developed by you. So therefore, microchip do give you all these pre-existed library like USB, graphic card, cryptography, smart card, TCP/IP. Okay, what to have a Wi-Fi support. Let's say, for example, if you have a PIC24, because PIC24 do not have a Wi-Fi capability. Okay, you purchase another chip called ENC chip. Okay, so that my PIC24 can go online. Okay, so probably you need a TCP/IP stack, in your microchip PIC24. Okay, like your senior, they do not need this because they're just directly linked with ESP8266. Okay, because ESP8266 is have a Wi-Fi module. Okay, so whatever signal coming from PIC24 microchip, you directly send to the ESP8266. But for this round, I try to split it. PIC24 is PIC24, ESP32 is ESP32. Okay, so you're gonna decide, which platform to use in your FYP. Not in your FYP, in your main assignment. Okay, is it okay? So any questions so far? Let me check. Okay, let me check. Okay, may I ask main assignment group? Okay, is midterm format similar to FA? No. Okay, so my FA is more towards I give you a case study. You need to go through Proteus. You need to develop something. Okay, is it okay? It's not tough actually. It's quite straightforward. But body long, I wish to ask Proteus, is it a demo copy will expire after some time or just don't have full features? Of course, the demo copy will expire. After that, you can't compile it. There's a lot of limitation later after that. Okay, so it's okay. Just if you're able to get a better copy, just grab the better copy. Okay. So class, any other questions you'd like to ask before we move on? I hope it's not very scary. Embedded system design. Any other questions from the floor? Okay, let's move on. Okay, so class, but class, those days, your senior, if they are using PIC24, they should have their own PIC 3. Okay, now got PIC 4 in the market. Okay, so they learn how to program it, and then PIC 4 also allow you to have a hardware debugging. Okay, so but of course we can't do all these things at the moment, so we are rely on Proteus. Okay, on the full to do the full simulation. Okay, so just briefly have a look of this, and for your information, those days we have microchip. Okay, microchip. You will learn PIC18 F4550. Okay, the advanced 8-bit microchip, microcontroller. Then those days we got Atmel as well. Atmel is using MCS51 family. Okay, few years back, MPLAB microchip bought Atmel, so that's why you found that all the Atmel processor belongs to MPLAB. Okay, so that's the reason if you have Atmel, you have your own programmer. Okay, so what are the differences between PIC-Kit and in-circuit debugger? In-circuit debugger, look at the price. The fantastic price. Okay, so it's faster. Okay, it's better and give you more breakpoint when you do debugging. You will learn all this later. Whereas PIC-Kit 3 or 4 is for hobbies. Okay, for student usage. Okay, you can burn the code, download the firmware into the microcontroller. I believe that you already used this before, in your microcontroller processor section. Okay, and do you know that PIC-Kit 4 also allow you to have a real-time debugging? What is real-time debugging? You construct your, let's say, during your microprocessor assignment, you construct the circuit. Okay, and you can using the MPLAB, put a breakpoint in the MPLAB. You run until that particular breakpoint you sync together with your hardware. Let's say that particular breakpoint is to lit up an LED. You put the breakpoint until there, you run until the breakpoint, the LED is lit on, on the hardware itself. So means it's doing in real time. Okay, so you have a real-time debugging capability. But however, PIC kit is a bit slow compared to in-circuit debugging. Okay, just a brief introduction. Okay, so here are the tentative syllabus. Okay, and remember, I will do a bit of adjustment. Okay, so we'll cover all the topics, but the adjustment is just we move around because we need to sync with the lab section. Okay, here are some of the syllabus. So section 1 mean lecture 1, we are doing a bit of introduction, then followed by C programming. When you learn C programming, okay, we also learning some of the C programming Arduino. Okay, then section 3 we will touch 8-bit, 16-bit, and 32-bit microcontroller. So 8-bit definitely is the MCS51 family, and you are quite familiar with the PIC18. 16-bit is PIC24. 32-bit, we are touching on ESP32 over here. So when section 4, we are touching real-time operating system. MicroCUS2 type with PIC24. FreeRTOS type with PIC ESP32. And don't scale by real-time operating system. Real-time operating system actually is easier than normal way of programming. Okay, because the whole operating system is given to you, and we rely on the operating system to run most of the event. Okay, so section 5 will touch some of the basic input output. Like most of you, at least you know how to connect LCD, keypad, ADC, and different type of sensors. So in section 6, we will touch on I2C, okay, and SPI communication. Finally, in section 7, we will full force an embedded internet, and we are looking into ESP32. Okay, okay. So let's begin our first sections. In this section, we will cover what is embedded system, what to consider in design, what is the obstacle in design. And class, remember, embedded system design is not to study microcontroller actually. Okay, so it's not to study ESP32. ESP32 or PIC24 is just a tool. Okay, so embedded system design is like this. So you're able to design a product. Okay, throughout the journey of designing, you will encounter a lot of problem. Okay, a lot of consideration need to be taking place. Okay, so we'll look at it over here. So the design challenge. Okay, of course, when you do embedded system design, there are a lot of challenges, things you need to encounter. So some basic definition of real-time system, and what is the embedded development cycle, and some of the existing example embedded devices. Okay, and finally, we look into the 2019 embedded survey. So every 2 years, I will look into the embedded survey to investigate whether we at the right path, whether our syllabus is really correct, whether is it all right we study ESP32, is it okay we study microchip, okay, or is it okay why we don't study other microcontroller, okay. Of course, I personally not quite keen, with MPLAB because it's quite slow, it's quite not very interactive. Okay, when you see Cowie Vision, you found that it's very interactive. Okay, let's move on. Okay, so before we start everything, any questions you would like to ask? And one more thing, class. Every in my lecture, let's say after an hour or towards the end of the lecture, we have a short quiz. I give you a quiz. You gotta answer the quiz. So everyone need to answer the quiz. Okay. So quiz, you determine your attendance. The quiz also, if you get all correct, I will give bonus mark. This bonus mark I will put it into your midterm, like those days. When we are in signal circuit and system. Okay. So is it okay? The quiz is very easy and very straightforward. Okay. Okay, there's some question. No, any other question? No questions. Okay. Okay. Any questions, class? Let's go back to hit this line. Where is our? Yes. Any questions from the floor? Yeah. Any questions? Okay, I think I need to switch this off because it's quite heavy. Okay. Switch. Okay, let's have a short break. Let's have a short break. 2 minutes break. While break, just ask me questions. Need to get a water. Yeah. And class, remember, this subject is an elective subject. Add and drop is within these 2 weeks. Okay, there's a question from Jing Hao. For the common practical, okay, so far you do not need any hardware. Okay, so it's purely on software. You need to download all the IDE, okay, like what I proposed just now, especially the microchip, okay, MPLAB, XC8 and XC16, and as well as CowU Vision. Okay, so this is the and of course Proteus. Okay, but of course when you come to ESP32, I will use ESP32 as to do all the constructions, and will show all of you. And this is this is ESP32. I don't know whether all of you know. Okay, this one ESP32. Can you see? I'm not sure. Can you see clearly? Oops. Okay, ESP32. Okay. It's just a very tiny and small chip, but it's very powerful. Okay, you can do a lot of things. Okay. No, we have okay. You said tutorial only got 4 classes. No, I mean, it's this. Where is my? Okay, here. Okay, based on the what I call that, the syllabus. Okay, let's start. Based on the syllabus. So topic 1, we take about 4 hours. There's 1 tutorial related in topic 1. Okay, we got 1 tutorial, 2 tutorial, 3 tutorial, 4 tutorial. We just have a total 4 tutorial sections, and we have 3 lab section, 1 lab section, 2 lab section, and 3 lab section. Okay. Topic 1, embedded system design. It takes about 4 hours. I try to finish it in 3 hours. Okay. So design 2 is 5 hours. Okay, but this is a lot, But I switch this become a lab section because it's a bit weird, to teach design tools as a lecture. Okay. Okay, and then for your information, I've been fighting, to convert this subject to become a full coursework, but in the end, every year my proposal is turned down. Okay. Okay. Then we talk about IDE. So the design 2 and IDE, we will do it in a lab section. I will give you additional lab section so that we can run the IDE to understand what is debug breakpoint. It's no point for me to say, oh, what is a breakpoint? What is step into watch window or click this, click that? You're just watching the video. So I prefer you to do it with me. You start your own MPLAB. I will do it over in my terminal. You also practice at your terminal as well. We do it in a real time. That's the reason I propose to have 2 terminals. Then actually, next section we start with programming. Okay, we have a C or C++ or programming concept, and then It studies 8-bit, 16-bit. Now I got 32 bits already. I put an additional thing for you. And just imagine, you know, embedded operating system, TCP/IP, web server, IoT, all these 6 hours. I don't think I can finish in 6 hours. I need more than that. Probably, you know, it take 1 semester, you know, just for operating system, for your information, you know. Those days when I'm in FICT, when I teach embedded operating system is one subject itself. Okay, I'm teaching Linux based. Okay, so it's not possible, you know. That's why I say this subject is a bit ambitious, and we do a major updating of this of the syllabus next semester, and then okay. Is it okay, class? Okay, and I also let you see. These are the teaching plan. I forgot to upload to all of you. These are the teaching plan. Okay, the task, lab 1, assignment, final assessment. Okay, we cover more on this PO. Okay, and then this is how this thing is being divided, okay, and this is how, and then tentatively I put the online test on 3rd of August. Okay, this is subject to changes. This one. Okay. So any questions? Any more questions? If no question, I will go back to our class. Let's go back. Okay, class. We do it step by step. I'm not sure where you are. Okay, I know some of you very good. Some of you got a lot of resources. Some of you are already expert. Okay, but some of you seems you send me an email and say you know nothing. Okay, no worry. I will start from very fundamental. I will go very slow. Okay, so those who are very good, you know, you can message me to discuss more. If you want more interesting thing, we can discuss personally. You have a personal discussion. Okay, so first of all, let us see what is embedded system design. Class, remember all the one I discussed here. At the end of the show, we have a short script. We have the quiz. Okay, we have the quiz. Okay, so what is embedded system design? There are a lot of definition of embedded system design, because embedded system design, this word is started in already so many years ago, in 1970. So that time, the technology, you know, is not as good as nowadays. So there's a lot of definition. So the one I just copy and paste from IEEE journal is that an embedded system is one that has a computer hardware with software embedded in it as one of its important components. You write the software, you type it, means this is a PIC16. So basically convert it into a hex code, and you just, or in the end we call it as a firmware. You download a firmware into the hardware, okay, to perform some function. So this is what we call as a embedded system design. Okay. So and some also say that embedded system design consists of a lot of electronic devices. Okay. Incorporate with microcontroller and microprocessor within the implementation. Okay, this is also embedded system design. There's a lot of definition for it. Okay, so here is one of the example embedded system design. This one, I think you enjoy this very much. A lot of junk food over here. Okay, so it's a vending machine. It's a vending machine. So vending machine is one kind of embedded system design. They got a microcontroller inside. Okay, so with this microcontroller, okay, we already programmed a microcontroller and we're able to control the input and give it an output. Okay, firmware is already downloaded into this microcontroller. So and then let's say the input, let's say I press 4. Okay, so the microcontroller, the input will be communicate with the microcontroller. If I press 4, it will display 4 in the LCD. It's very simple. So the 4 LCD means number 4, probably I'm not sure. Then the number 4, this particular stack will drop down. Okay, so nowadays, and those that embedded system design is a dedicated function. Nowadays, embedded system design, there are a lot of functions. For example, and this is out of stock, it's wirelessly sent to the supplier, say this particular terminal is out of stock. So there are a lot of function in one embedded system design nowadays. We got a get position sensor, coin, but in the end, one dedicated function at one time. Press the input, display an LCD. I press an input and display LCD. Okay, I press the input, probably I will activate the gate actuator, but two of these things is not happen at the same time because we are not using dual core and quad core microcontroller or microprocessor. But if you are using ESP32, ESP32 have more than one processor. So okay, I will teach you how to utilize two processors at one time, okay, in future. Okay, let's move on. So there's a lot of embedded system design out there. Just name it at your home, anything in the industry, home usage, okay, your university, everything is embedded system design. So all these things are embedded system design. But however, this kind of design is just have a dedicated function. Okay, let's say for example, anti-lock brakes. It just anti-lock the brake ABS system. Okay, I'm not doing other things other than lock the brake. All right or not? So okay. So before we move on, students need to understand the difference between the generic computer, the computer that you have in your home. So that one, everything is separated. We have a microprocessor, we have a main memory, DDR memory, your own network card, graphic card. You have a very powerful graphic card. Not just at your home, you have a very high-end graphic card, not in the microcontroller, not in your ESP32, okay, not even in Raspberry Pi 4, although it can support HDMI, all these things, okay. So these are the differences. But however, if you talk about embedded computer, is small, tiny, so most of the things is already integrated into the microcontroller. For example, nowadays microcontroller, ADC, SPI, I2C, UART, RAM, counter, everything is already integrated into the microcontroller. Okay, let's move on. Okay, so so far in your microcontroller, microprocessor, you are just using this generic embedded system design. You got a processor, you got some memory, okay, already integrated into the microcontroller. You just control some input output, probably move the motor, or move the robot, move the DC motor or stepper motor, turn right, turn left, okay, all these things, or RC motor, or light out an LED, run and 7-segment. So this input and output. But however, some basic embedded system design, you always have a bit high end, a bit medium end, the device driver. Probably you can write a device driver for your LCD, device driver for your keypad, and so on. Okay, and with then some application. Okay, then for more complex real-time operating system is inside with TCP/IP stack. Okay, and with all the device driver. So we will go to the complex embedded software design by that. I mean in our study, in this study. Okay, so let's look at, before I look at all the hardware, before we go to all the technical, okay, let's look into the challenges. Something that you need to think, when you come to embedded system design, and you are quite lucky such that everything is given to you so far in the lab. Let's say you want to run a lab experiment. All the components is given to you. You collect all the components from the lab assistant. You're not the one who decide what component to use based on the experiment. Okay, so when you're going out to industry, let's say you set our own company. Okay, you want to set our own company. Okay, you want to design your own Malaysian make mobile phone under your name. Okay, so then you will create a mind. You got, even though you got 1 million, 10 million, you're very rich. You want to start a company. So you ask yourself, what microcontroller you want to choose, what kind of LCD you want to choose for your mobile phone. Okay, so that is a big question. Yeah, I agree, such that you can hire some good engineer to decide for you, but you yourself also should understand, what is the critical things, what are the issues that you must encounter in the embedded system design flow. Okay, let's begin. One is the energy efficient. It depends on the application. Are you designing a pacemaker? Pacemaker, the one you put into your heart, you got heart problem. Okay, doctor will send a patient, to the operation theater, cut it and put the tiny thing into near their heart, So you don't tell me that after 1 month, out of battery, I need to remove it again and install a new one. It's not possible, isn't it? This is not what we want. Okay, so you have to consider all these things. You have to decide how to ensure the battery will last forever. Not forever, at least 50 years. Okay, normally we got heart problem and you have reached 50 years, then you wouldn't live until 100 years, example. Okay, so unlimited power, ventilation control. This is you always ask this, energy efficient, real time. Is it need to be real time? Let's look at this chart. When you talk about real time, you got 3 different sections: non-real time, soft real time, hard real time. Let's begin with hard real time. Hard real time means time is predicted. Let's write something. Is predicted. This one is diluted. This one doesn't matter. Okay, predicted means what? Let's say, for example, airbag. So when a car hit the wall, the airbag will be released. Remember, airbag is not released immediately. There's no such thing called immediately. Okay? So predicted means that the airbag have to be released in 10 milliseconds, for example. So this 10 milliseconds is already tested in the lab, okay, with the mannequin. Okay? So if more than 10 milliseconds, the passenger will definitely in big trouble. Okay, so this is called a hard real time. So when you got a hard real time, you need a real time operating system to carry on these services. Okay, so soft real time means the time is diluted. What do you mean by diluted? Within 20 to 30 milliseconds is perfectly all right. Okay, that is what we mean by diluted. Let's say, for example, when you watch a movie, the frame per second, 20 frames per second, 25 frames per second probably is not much different. You wouldn't see, or even though it's very slow, it doesn't matter. It wouldn't bring any problem, to the user. Non-real time, you don't care. Let's say you run a simulation, you run a deep learning simulation. It takes 2-3 days. You still wait and wait and wait. It doesn't matter. Okay. So here are the 3 things you need to consider. These 3 things will determine whether should you use real-time operating system. You should use hard real-time operating system or soft real-time operating system. Okay. And remember, all the Windows 10, all these things it's just the ordinary operating system. Okay. Then we come to safety critical things. Okay, is it you are dealing with nuclear plant? Are you dealing with COVID-19? Example nowadays, the testing kit. So if the testing kit is not accurate, you create a lot of problem. So that's why it's very important when it comes to design. So make sure that you use the correct things. Like for example, toy, electric toothbrush, toy. Still remember when you are in kindergarten, your father bought you electronic car. Is it still working nowadays? I'm not sure. I likely no. Probably if this is an electronic, I'm sure that the battery will definitely, if you keep the battery inside, definitely gone. So there's if you're able to retrieve back your old electronic toy, let me know, PM me. Okay. So and then upgradable. like spacecraft, you send the Land Rover to Mars. Impossible ask them to come back to do update, correct or not? So you have to using a wireless update, okay, and power by solar, all these things, you need to consider. So, and is it easy to update? Okay, like nowadays, updating, you learn from me later in ESP32, I will talk about on the A updating. So you updating, suddenly you receive, like for your handphone, you receive all your firmware need to be updated. So it's OTA. So on the A updating, how to do the on the A updating, okay? And what is the disadvantage of on the A updating, okay? You look into it later. And cost sensitive, of course, ordinary product like mobile phone, okay? 2,000-3,000, okay, fine, Huawei 2005 nowadays, and then iPhone very expensive, is still considered cheap. Why? Because if you talk about military process, military application is very, very expensive. So that's why when it comes to design, which project you are getting? You're getting a military project, you got a multi-billion funds. That's why you might be using a better design or better quality of devices. Okay, then highly available and fault tolerant. Okay, same like what I told you, to operate all the time. Pacemaker, can shut down all the time. Cell phone, it doesn't matter. You cannot, allow pacemaker to shut down. Okay, so you make sure that it's operate all the time. Okay, they got a backup battery or backup, I don't know, something backup, to prevent things to malfunction. Okay, the security. Okay, security is one of the issue especially when it comes to IoT. Okay, like RSA, DES, all these things, encryption, will part under the security. Do your embedded system need security or not? Okay, so in the end, it's basically, we can summarize reliability, power consumption, portability, your embedded design. If you design mobile phone, you don't want your mobile phone like those day 1980s as big as a water bottle. Okay, it's portable. And complexity, how complex is it? Is it easy to use for the user? Okay, you design your robots, you design your own things. So in the end, how easy, for the user to use it? Or press one button, he will do everything for you. Okay, that's very important. And of course, the performance, we talk about multitasking, all these things, accuracy. So when you come to design, performance is one of the very important things as well. And sometimes we have to mix with analog and digital. Most of the sensor give you analog, you must understand analog digital conversion. Okay, so this is some of the things that you need to understand before you come to embedded system design. Product lifetime, definitely. So real-time processing, which I discussed with you just now. Again, hardware and software core design and restricted memory. So example, if you want to design, I ask you to design, just switch on and off the light. You're not going to buy Raspberry Pi just for switch on and off the light. Am I right? So, and sometimes, let's say for example, I'm using PIC24. PIC24 maximum got 64K of program memory. So you keep on putting in TCP/IP stack, you put in that, put in this, put in that. So eventually you run out of memory. So you have to ask yourself, in your design, in your programming design, should this allow memory? How much memory do you have in the design? So all these things you need to consider before choosing a proper microcontroller and proper devices. Okay, so finally, this is some of the common metric. You also need to know some of the things that is important as well. Unit cost. So unit cost means how much the cost of one product per unit. Okay, this is just a manufacturing cost, excluding a non-recurring engineering cost. Okay, unit cost means cost of basically it's a manufacturing cost. NIE is a development cost. These are the costs, the process, the total time, the total what kind of tools that you spend on the development on during the design. Let's say, for example, I want to create a mobile phone. My team sit down day and night for 3 months typing the code, all these things. Okay, what kind of equipment to use? This is called a NRE cost. So normally, that if you have a mass production, NRE cost normally is high. Why high? High means you can produce better quality of devices. Why? Because they spend so much time. You have a big team. Let's say, for example, like PlayStation 5, very high NRE cost. They're using a very good component, but they're able to sell it with thousands or millions of copies. That's why in the end, the cost of that product will be less. Okay, we look at it later. Okay, of course, size, whether it's the weight, it's all considered, in your design. This is the external outlook. You don't want your handphone small but 10 kilo. We don't want this, correct? We want light, we want size tiny, I don't know, cute. Okay, I'm not sure. Okay, some say bigger size better, the screen is bigger, it's nicer, so it's up to the user. The power, the amount of power is consumed by the system. The flexibility means that the ability to change the function of the system without incurring a heavy NRE cost. Example, PlayStation 1, they spent a lot of, it's very expensive, high NRE cost. But when it comes to PlayStation 2, the NRE cost definitely will be reduced because they already have an existing sample, existing code, of PlayStation 1. So this means that when you come to your program design, make sure you do it. Make sure that you have your design is flexible. You don't want that 360 degree change. Like for example, like Samsung 20. Okay, I'm no longer using no more LCD, no more screen. Okay, the Samsung 20 just embed into our brain. No, I mean, there's no flexibility here. Definitely, NRE cost become very high. So we don't want this. Time to prototype is also very important. Time to prototype is the time to get the investor. There's a lot of Tesla car. You see, wow, very interesting, correct? So in the end, whether you reach the market, I'm not sure. But time to prototype is important, such that you release the prototype to trigger the market, to let everyone know we got such design. Okay, so then time to market also very important. Like why is important? Like example, the whole world are racing to get the vaccine to be done. Vaccine of what? Vaccine of COVID-19. China is developing, Europe is developing, USA you're going to come out. UK mentioned, if I'm not mistaken, they already do a major testing on human. Why? Because the first country, the first company who hit the market, definitely they will make a lot of money. Just for information. Okay, so maintainability, so the ability to modify the system. Okay, so corona safety and many more. Okay, so all these things you need to consider before, let's say you're given a specification, giving a project. So all these things you need to consider. Okay, so if you want to hit the market, you are not doing research. Research is another issue. Okay, if you want to hit the market is, you have to consider all this. Okay. So this is a classification of embedded system design. I already told you just now. So small scale like PIC 16, like Atmel, PIC 24, all these things, like ESP 32. Okay, you are not going to get this thing solder, correct or not? You're not getting this thing and put into your breadboard. Okay, but however, this is the one you always use. Okay, dual inline packaging. Okay. So some is sophisticated. Sophisticated is like ASIC design. I told you it's application specific integrated IC. So it's based on the applications that will produce the IC for the company. Let's say a company want to do this thing. So that's why we design according to their needs. Okay. Okay. So small scale embedded system design, I told you already. 8-bit, 16-bit, involves some RTOS. Okay, we are still in the medium scale. Okay, even ESP32, we are doing medium scale. So large scale is involve a lot of configurable processor, FPGA, all these things. Okay. Okay, let's talk about real-time embedded system. Just a brief, introduction. So, okay, just give me a minute. Okay, let's have a one empty slide. Okay, still remember those days when you write your program? How do you write? You say, well, one, or in your code, then you short jump again, correct? In your assembly code, again is here. So this thing is keep on repeat. Am I right? Okay. Yes, of course. Okay. So if you're doing real-time operating system, we have each task have one by one. By one, do for all means by one, not by one. Keep on doing here and here. By one, here and here. By one, here and here. And we let it run at the same time. So it will run. Okay. So operating system, the real-time operating system, they got some inside got something called scheduler. Scheduler will decide, the switching time to switch one another. Okay, they switch back and switch back based on some algorithm like round robin, first in, first out. Okay, is it all right? Okay, so they'll jump back again and again. Whereas for this one, yes, you got interrupt here. You jump to the interrupt service routine. Even by one, you jump here, you come back here. Okay, so but not the case for real-time operating system. Real-time operating system, everyone is like this, and each of them also maybe got interrupt as well. Okay, so this is a real time. So everyone is have their chance to run. Okay, we'll look into this more details in the real-time operating system chapter later. Okay, so you see, when you come to development, we have two teams. One is a hardware developer, one is a software developer. So to become a successful software developer, and class, remember, what I mean software developer is not like those database like computer science students, they are using Visual Studio, develop their software, develop their own inventory system, key in the name, not that type. What I mean is an embedded based software developer is embedded here. Okay, embedded based. Okay, so become a successful embedded software based developer. Here are the things that you need to consider. First, you need to have a very good hardware knowledge. If you're using PIC24, you don't know the input-output pin, you don't know all the informations, the details of the hardware, then you can't be a embedded software developer. Okay, so this is very important. So this means that your hardware knowledge need to be very, very strong. Okay, and when you write the code has to be efficient. You see, yes, it's true. Let's say 10 of you. Each of you write different style of code. Okay, impossible when you submit your final assessment is the same. Impossible. Okay, so the efficient code means that your code have to be clear. If the code is clear, short, when you compile it, when you generate, the size of the code is very less. Okay, this means it's a good code, of course, provided that it can carry out perform the task. Okay, so efficient code means the code is clear code. Okay, and of course, the software developer means you need to understand all the peripheral interfaces. Let's say, for example, if I give you a keypad, okay, you know how to deal with keypad, all the pin in the keypad. Or if I give you I square C LCD, oh, I know, okay, I just got SCL, SDA, okay, 2 line round, okay, I know all these pins. So I will write I design my code accordingly. Okay, the code that you design had to be robust. Robust means that is a easy what call that okay, let me remove this first. Robust means that the code okay, the code can handle different situation with minimum error. Let's say, for example, I write this code, I connect to LED, you know, with this power, with this exact LED one. Then I migrate to different type of LED, different model, so it still gives you the correct result. Okay, you know what I mean? Okay, so minimum resources. So minimum resources means you're doing software developer. So this means that if you do not have a lot of debugging, hardware debugging tools. Still remember just now, when you come to debugging, we go through few stages. First, we write our code, we compile it. When compilation got error, we correct it. Okay, okay, this is compilation error. So no, when you compile all perfectly, all right, you download into your devices, but it cannot perform what you want. So this is a big problem. So you need to do debugging. So in this debugging, you can using oscilloscope, you can using like Pickit4, put a breakpoint, do a real-time debugging. Okay, so when you involve Pickit4, it's a money. Okay, so it means you're already utilizing some hardware debugging tools. So things are getting more expensive if you're using BDM, okay, like the jet, like just now the in-circuit debugging. Okay, all these things is money. So if you're able to solve your problem with minimum resources, that's fantastic. Okay, so remember, debugging is the toughest, you know, in embedded system design. Okay, and finally, what you write, your software, you had to write such that the software is reusable. Reusable means that it's easy for you to do migration. Let's say, for example, you write your code using microchip. Okay, then suddenly your company say, "Oh, I don't want microchip." The customer said, "I don't want microchip. I want let's say Hitachi or STM microelectronics microcontroller." So then you can do a migration, okay, and you have to show that your code is reusable. Reusable means that you can cut and paste your the root of the code, you know, then able to migrate to other microcontroller easily. We will try to do this, you know, in we try to migrate microchip into MCS51 family later in our lab section. Okay. So of course you must understand different type of development tools. Okay, you're a software developer, you still need to do debugging. Let's say, for example, I'm using ESP32, or I can using Lua, I can using Arduino, I can using MicroPython to do the programming, you know, the development tool that we want. Okay, and I don't want to construct my hardware first. I know that such thing called Proteus. Okay, to do like looks like a hardware real-time simulation. Okay, so these are the things that embedded software developer need to have. So remember this. So this means that when you go for the embedded software developer engineer, make sure that you have all this knowledge. Okay, so and of course, like what I told you just now, when you have a product requirement, you need to divide your team into the hardware and firmware, software basically. But of course, we have a problem here. You know, we can't access the lab. We don't have hardware like PIC24, all these things in the lab. Okay, we try to move everything into simulation just to protect you. Okay, yeah, and you must know how to draw PCB, but no problem. I will teach you how to draw the PCB, all these things, you know, all these things can be done in Proteus. Okay, so firmware design definitely. Okay, So not only that, when you come to embedded system design, you also need to understand the market. What is the hottest thing in the market now? Of course, it's the vaccine for COVID-19. Okay, so that's why everyone is going towards this. Okay, but going towards this research, we need cost. When is the time to market? The performance, the power, all these things might be involved if this is an embedded product. So we try to find the optimum point. Sometimes our low cost, low power, highest performance, shortest time to market is very difficult to be achieved. You want good things and cheap things. It's very difficult. I didn't say no, it's tough. Okay, that's why you need to understand the market. What is the current situation now? Let's say what is the cost? I mean, people doing this and what they are lacking, and what is the current market? You know, in the power analysis. Okay, so all these things you need to understand before you carry on embedded system design. You not just go and perform your thing blindly. Okay, doesn't mean that you have very good technical knowledge, you're able to survive in the market. Okay, this is very, very important. Okay, so that's why embedded system design is not only talk about technical, it talk about physics, it talk about marketing, it talk about a lot of other things, you know, to ensure your product is being designed. Okay, so like this example, this is a digital camera. So how should it very high NIE cost? Yes, very high NIE cost. How's the size? How's the power? How's the performance? So we have to find a point, you know, so that it complement one another. Okay, so this means that when you want to design this, so your customer asks you to design this, so you are alone, you don't have much experience. That's why you need expertise. You need to get an expertise to, you know, from both hardware and software, you know, to do all these things. That's what's the reason. Some company hire you, you are expert. They give you 6,000 per month, example. So, but once you develop this digital camera, Malaysian make, he make billions, and he just give you bonus 2 months, example. So I mean, that's the fair market lah. Okay, for information. So let's move on. Why time to market is very important. So this graph is to show you that the peak here is a maximum revenue. Okay. Okay, let's just go to an example. Okay, let's say this is the when it's on time, so, and let's say this is a W here, is on time, we have make the maximum revenue. So let's say US and China compete one another. If China hit the market, we make money, right or not? Okay. If there's a delay, definitely there's a loss. Okay. So that's the reason. If I give you a deadline for assignment, make sure you hit it lah. In university, marks will be deducted law. In outside world, your pay will be cut law. If delay, this is a fair world, am I right? So here an example. If 52 weeks, I delay 4 weeks. Lifetime, let's say I predicted the COVID-19 vaccine, the lifetime is just until December. After December, possible COVID-19 will be disappear in this world. Example, just like SARS, you know. SARS is just disappear, all right? Even the vaccine is developed, it's disappear. So if it's a delay for 4 weeks, my loss is 22% off. If it delay for 10 weeks, the loss is 50% off. So it's fair also, you know, when you delay few days, then marks will be deducted law. Okay, so there's so that you learn the lesson such that it cannot delay. You have to meet the deadline. So that's why a lot of company, a lot of outside world, when you give a project, the deadline is 2 weeks, then you have to complete it within 2 weeks. You know, it's just like a war, you know, in a company. So make sure that you have to, deadline is very, very important. Okay. Okay. So we come back to the non-recurring engineering cost, which we discussed just now. Just have a brief introduction. Okay, unit cost, I told you just now, Unit cost is the manufacturing cost, excluding NIE. NIE is a one-time monetary cost. So the total cost will be the NIE cost plus unit cost per unit. Okay, unit cost of multiplied number of unit, correct? Not the total cost. Okay, if you got 1 million, then you got 1 million unit lah. But remember the pre-product cost. If you got a lot of units, your NIE cost is divided by number of units. So this will be diluted. Normally the NIE cost is very high. Why is high? Because this is the time your team spending, in developing. Okay, that is, you use your brain, you hack your mind, you sit down in the office day and night for 1 year to come up with that product. So that's why NIE cost is very, very high. Remember, NIE cost also consider how much time you spend, how much of electricity you use, the rental, all these things, development cost, how many line have you, the length of the line code have you written, all these things, in the NIE cost. So that's why NIE cost will be reduced if a number of units is very, very high. So this indirectly will reduce the price of your devices, of your product. Okay, just like example, like if you're able to come out something, the whole world will use it, then you become rich. Not only rich, you can sell it at the reasonable price. Okay, so here is some of the example. NIE cost, the unit cost will be very high. However, if the volume is reducing, your unit cost will become reducing. So remember, normally high NIE cost means you produce a good quality of product and design. Okay. So here is some of the example. So different technology, you can have a look. Okay, but make sure that you should consider time to market lah. So that doesn't mean NIE cost I need to spend 20 years to come out with electrical car. Tesla already come with electric car. So after 20 years, Malaysia come out with their own electrical car. Then, what do you think? So people, in outside world, if you don't know where they are, of course, our Malaysian government help the like Proton, to give higher tax for overseas car. Okay, instead actually they are quite cheap. I believe that you already know this. Okay, just move on. Okay, so when you come to design, always ask yourself all these questions. Is it single react? Means basically ask this question. You ask all these questions. When you come to design, do you really need all this? Okay. I hope it's clear. So any questions so far? Yes, let's look at any questions. The latest version ESP32 is a single core. You really? From Nicholas, but so far mine is dual core. I don't know. And we need to have a look. We need to check. Okay. But so far, all the ESP32 that we have in the market is dual core. Okay, it's based on the. I have the data sheet. You go and check Okay. Okay. So let's look at this. This slide is very interesting. So is everyone still okay? Still with me? If yes, please raise your hand. I want to have a look. Or you already sleep because it's after lunch. Nobody raise a hand means, yeah, please raise your hand. Everyone is still alive. Okay. Okay, are you sure? Just how many of you actually? Okay. Okay, let's have a look of this. We got a quiz letter. Okay, this one is very interesting. Okay, we come back to. We just rest for a while. Let's switch off the camera because it's very hot, over here. Camera is on. We come back to our this slide. Okay. Okay. So this slide is very interesting. There's a lot of things can be discussed, in this interesting slide. Okay. So types of microcontroller, they got of course they have 8-bit, as you know that. Like example, 8-bit is PIC18. Okay. Like most of the MCS51 family is MCS51. You can Google a bit. I write it nicely. PIC18 like MCS51 family. Okay, because this is a conventional type of microcontroller, but it's still in use. Okay, in the market. Okay, so PIC16, I just briefly mentioned, like PIC24 is PIC16. 32-bit, we got PIC32. We also got 64-bit nowadays. It's moving up. Okay, and like ESP32 is 32-bit. Okay. So when it comes to memory devices, so most of the memory nowadays is embedded. Okay, especially for microchip. All the microchip is all embedded, whether it's a program code or data memory. A program code or data memory lah. Program memory or data memory. I mean, program code means program memory is the same thing lah. It's a code. Okay, so data memory. Okay, it's embedded. So, but if you need to store your data, I mean store data like temperature, so you can have external memory. The external memory can be a EEPROM, it can be a SD card, it can be your micro SD card, it can be other storage element. Okay, so normally nowadays, I mean, we consider everything is embedded. Okay, okay. Those days, like MCS61 family, we need a lot of wiring. We got external memory. Okay, we got external memory like 2C, 64, all these things, but you need a lot of connections. Okay, so of course you got external memory. This is a conventional type those days, but we still got nowadays. We still, if not enough, you still need to use external, but it's not really recommended lah, because it's very tedious. Okay. Oh, this one I missed out this one. And when it comes to design, we got an IC chip, and we also talk about the VLSI. So remember, VLSI is just the process to create an IC. Okay. So actually, for embedded system design, it should be related with VLSI design, just for information. Okay, so if you are hardworking, please master Verilog, at least Verilog. Verilog and VHDL is a bit different. I prefer Verilog. So this kind of language is called a HDL language, high definitive language. Okay, so it's very demanding outside. Okay, just to share with you. Okay, VLSI design. VLSI means very large scale integrated. Okay, VLSI design. Just to share with you. There are a lot of different type of things. Okay, when you come to microcontroller, of course, microcontroller nowadays is evolving. So this one is no longer applicable. Why I say this? Okay, let's begin. We got X051. Okay, a lot of people say it's been obsolete, but actually it's still quite popular. Not popular as a consumer electronics, but it's popular in industry. Okay, so when you talk about X051, X051 actually is started by Intel in 1980s. So Intel at that time thought that low power devices don't have business in the market, so they give up this. They just stop produce microcontroller. Okay, for your information, they are targeting on desktop. They are targeting on server base. But do you know that for the past few years, low power is coming back? That's why Intel is moving back, to the low power design. So, but anyway, for X051, Intel, once Intel give out the license, the proprietary, so then a lot of manufacturer, you name it, from Philips, Atmel, Siemens, all these things, you come back, and use that architecture to develop their own 8051 family. So this means that all these IC, you just need one IDE, which is Micro U Vision, okay, which from Germany, which I told you just now. Please download Micro U Vision 5. And of course, Philips is no longer involved, in the semiconductor line. Okay, actually, Philips and merged with Freescale, former Motorola. They name it at NXP. Okay, so NXP is become quite popular nowadays. Okay, so NXP is from Holland. I hope that you know this. Okay, please go to their website. It's one of my tasks in tutorial 1. This, I think, is from Holland. Okay, NXP. So Atmel is very popular those days, and it bought over by Microchip. So they are merging. So there's so many changes. They merged. Microchip merged with the Atmel. So Atmel those days come out with Intel 8051 as well. The popular one is a 89S8253. Those days is very popular, and also AVR is very popular from Atmel. So that's why Microchip bought over Atmel. It become a very big family. So, and he already take up half of the microcontroller market. Okay, so remember, Microchip is their own Microchip PIC 16, PIC 18, PIC 24, and PIC 33 or DS PIC 33. 8051 is different. 8051, they got different manufacturer. They're using the same family. Okay, just for information. So then we have Hitachi. So same Hitachi. Hitachi. Just to share with you, just some history of Hitachi, just for leisure. Hitachi also actually he merged with Mitsubishi. Like car, actually they are involved in a Japanese company. They involved in semiconductor. They merged with the Mitsubishi, and they have their own new line called Renesas. Okay, Renesas. Okay, it's Japanese. Okay. Then we have Texas Instrument from US, very popular. Okay. And we also got Siemens. Siemens also is a Germany company. Those days very popular, my Siemens handphone. Okay. So Siemens already renamed, also bought over, they name it as an Infineon. Okay, it's a Germany company. We got Dallas, we got ARM. Of course, ARM is from UK lah. So ARM also evolving. We already have ARM 11, different kind of ARM, A, B, C, D, E. Okay, ARM is ARM microcontroller. Okay. Okay, this ARM is related with the RISC architecture, advanced RISC machine. Advanced RISC machine. RISC is reduced instruction set computer. CIS is complex instruction set computer. We talk about this later. I hope that you already know this under microcontroller, microprocessor. I just briefly repeat everything that you have learned. So ARM. So remember, ARM is from UK. So ARM is fully support Micro U Vision. So everything like STM microelectronics, they're using ARM. Definitely Micro U Vision is recommended. And of course, they got others microcontroller. Of course, the most important nowadays, something that is really, really trigger the market. People talk about it. Of course, is this one, correct or not? HiSilicon. Do you know HiSilicon? It's the one who produced the Kirin processor. Okay, the latest one is 990, if I'm not mistaken. Oh, ouch. Okay, how? Yeah. It's all gone. Okay, never mind. So it's a Kirin microprocessor. Okay. Okay, it's 990. All this information you get from the internet lah. It's no worry. Just a sharing section on it. It's just a sharing section. Okay. So let's look at the instruction set. This is more important. Okay, let's look at the RISC and CISC architecture. So this is a more important things because those days when I'm conduct interview in Intel, I always ask this question. I don't know why still a lot of students can't even grasp, understand what is a CISC and RISC. Okay, CISC means reduced instruction. C means a complex instruction. Okay, so can you put in a checkbox? Can you tell me microchip is RISC or CISC? Yes, anyone? Where is it? Anyone? Okay. Microchip, yes, very good, Nicholas, Ziani, and Yong'an is a yes, it's a reduced instruction. Okay, before we move on, okay, can you tell me now, microchip, is it using Harvard architecture or Princeton architecture? Can you put in the checkbox? This one, Harvard architecture or Princeton? Princeton means von Neumann architecture. Anyone? Memorial architecture. Yeah, I'll give you some time to put in. Okay, very good. It's a Harvard architecture. So okay, let's briefly go through what is all these unique things, So reduced instruction. Why microchip is using reduced instruction? Basically, most of the microcontroller nowadays they are using reduced instruction set. Reduced instruction set computer. Okay. Why? First reason, when you read list, we got a large register. I believe that when you study microcontroller, microprocessor, you can see a lot of register R0 until R something, I don't know. I think it's a lot. I think more than 32 or something, 16 or 32 register is quite large. So when the register is large, it's easy for you, okay? So, but the only problem of RISC instruction is because it says reduce reduce means the number of instruction is less. Okay, so if you are the assembly engineer, you don't have C programming, you write everything in assembly code, so it give you job is tougher for programmer. Why? For example, if I'm not mistaken, PIC 16, you just have 35 instructions. You know as instructions are all these compare, add, add. So why? Like PIC 16, if I'm not mistaken, they don't have divide instruction. If I ask you if you want to do divide, then you need to do subtract. A lot of subtract will be used. So that's why it's very tedious when you come to programming. So like PIC 32, PIC 18 got 75 instruction. Okay, fine. PIC got 75 instruction means that they already include divide instructions. Okay, not like CISC. No, CISC got more than 100 over instruction. This one I think is more than 100 plus instructions. So that's why it's easier. I mean, when you come to design. Okay. Okay. Another thing is, so in RISC, 95% of instructions is just using one clock cycle, and 5% normally, if I'm not mistaken, 2 clock cycle. This one is more. It's more than 3. Some is 3, some is 4, and so on. Okay, so that's why it's quite slow, compared to reduced instruction. Okay. Okay, so because RISC instruction, RISC instruction have a large number of instruction. That's why number of transistor used also a lot. Okay, okay, and this means that they have many addressing mode. I believe you already studied microcontroller, microprocessor. If you're using CISC instruction, the number of instruction is less. Let's say I write something here. Okay, I add another thing. So Sys has a larger number of instruction. Okay, so many addressing mode law. So remember the immediate addressing mode which you have to learn. So this means you need a lot of micro instruction. Sorry for my handwriting. Yeah. I have to go back. You need a lot of micro instruction. When you need a lot of micro instruction means you need a lot of CPU. A CPU you need a lot of transistor. Means you need a lot of micro instruction. You need a lot of transistor. Okay, it's increased. Okay, compared to RISC. So that's why the beautiful of RISC is just hardwire. Okay, sorry, hardwire. I believe that you already learned computer architecture under Dr. Lian Zhao. So I believe you know all these terms lah. Okay, it doesn't matter. Just to let you, hardwire means they are connect using hardwire rather than using micro instructions. Okay, so this means that it's quite promising lah when you're using RISC architecture. Okay, is it all right? Okay, so some of the thing. Okay, before we go to the quiz, let's finish one more thing. We keep this and we go to this, and then we talk about Harvard and Princeton architecture is quite straightforward. Okay, so we make it straightforward. So Harvard architecture. You see, okay, let's say when we want to store something store our program into, when the CPU want to store a program, normally divide into two sections. One is a program memory, one is the data memory. Correct or not? So so for Harvard architecture, where is my pen? For Harvard architecture, the CPU divide, the two sections of address, the address bus and data bus, to the program memory, and we have a separate, address bus and data bus for the data memory. More wiring, but faster. Okay, this is inside the CPU lah. But for this is Harvard architecture. For the von Neumann architecture of Princeton, another name. This is the older version of architecture. So the CPU basically sharing the address bus and data bus, to the data memory, to the program memory. Okay, so that's the reason they claim Princeton is slower, but Harvard is more wiring. Okay, so that's why a lot of people moving to Harvard. Okay, a lot of people ask me, a lot of researcher, come out say that, oh, Harvard is better. For me, I can't say Harvard is better. Why? Still remember those days when we are your hard disk. So still remember hard disk those days you are using called parallel ATA. I hope that you still remember those days. There's a lot of when you in your hard disk, you connect a hard disk to your motherboard. Okay, your hard disk is a parallel ATA. It's a 40 line. 40 line is like a cable like this, red color here, correct? Then 40 line. Then you move to 80 line. It's faster. Okay, parallel ATA. Then nowadays we move to serial ATA SATA. So it's still fast. It's still very fast. So we now until today, Harvard is still better than von Neumann architecture. We don't know in future what will happen, But so far, Harvard is the best. We implement this in most of the microcontroller. Okay, so what's the time now? Okay, we still got 3 minutes. Okay, so before we move on, you can click into this. I post this. It's just a very short quiz. Okay, very easy. A, B, C, D only. You can finish within just for a while. Okay. Okay. just click and answer this simple quiz. It's very simple. Just click it and see what happens. I need permission using a Utah email. Use your Utah email. Are you using a Utah email? Can you go in using a Utah email? Because last time you all of you using Utah email. If you're using a personal email, I don't know. Last time I'm using personal email, but you guys always use Utah email. Keep on sending me message. Using Igniter also can. Oh, really? Connector. Okay, I never tried before. Okay. Xiangli, can you go inside? Can you go into this website? Cannot? Xiangli, can you use your Utah email? You log out your personal Google Mail and log in using your Google using your Utah email. Because I create the form is created using Utah Mail, Utah Google Form account. So no worries, Xiangli, you got plenty of time to do that. No need to rush. How many of you still got class after this? FYP. FYP discussion. This is 3 o'clock. Okay. 3 o'clock. Let me check. Three questions, not tough. Yeah. Hi. Oh, one more thing. Okay, class. One more very important things. Okay, just for a while. Okay, is it possible this coming Thursday, our lecture start at 4 o'clock, 4 to 6? Hi all. Is it okay? We start from 4 o'clock. Yes. Who not able to make it, please send me a message. IDP meeting for 20 to 30 minutes, 4 p.m. No, this week, not next week, this week. Man Sing, you got a 4 p.m. You got a IDP discussion. Man Sing, I need everyone know can make it. Man Sing, can you make it? Man Sing can make, because I found that all of you have the same tutorial, ma. Man Sing, can you make it? We have a 2 hours, 4 to 6. Where is Man Sing? Can Gua, sure or not? Make sure that you can, so I don't want you to miss out something, so else I'm in trouble. No, I don't want you to see the recording. So recording is something that I don't really like, it's very boring. Okay, anyone who cannot make it on next lecture this Thursday, just this Thursday, so that we can try, 4 to 6. And anyone cannot make it also, next week, because I'm not sure still got newcomers or not. You still can drop this subject. Next week, can we try to make we start our pre-lab. Second week too, pre-lab. It's just a pre-lab. Okay. So because normally for lab 1, 3 hours is not enough. Next week, this is next week, not this week. So I just worry that this week still got newcomer. Next week should be no problem, isn't it? I just worry that you got.
Next week 9 to 12 one, I have class on 9 to 10.
Oh, you got your class 9 to 10.
Yeah.
Okay, no problem. Then cancel. Next week we don't have lab. You don't have lab. So so no, don't have. I want to make sure everyone can make it. Just now is who? Is it every week? Is it every week?
Not even.
Even week.
Yeah.
Even week. If you do it this week, yeah. Even week. Even 3, 4, 5. Yeah. Is it possible we do it this week? Anyone cannot make it this week? 9 to 12. Since nothing happened this week, I just want to ensure that everything is in order on it. Okay, please start installing all these things. Is it possible this week? Hi, class. Again. No is 4 to 5. What is it? Can we make it this week? We have a lab section. Just a pre-lab, pre-installing only. It's nothing much. Okay, I want to ensure everyone install all these things into your system terminal appropriately. Even though you successfully install, sometime when you compile the code, it won't work, that's the problem. Okay, so I will upload a very simple code, pick 18. So you can just run it probably. I upload some video probably. This Thursday morning can. Okay. So Who cannot make it this Thursday morning? Or can? This Thursday morning lah. Okay. Well, first week already a bit heavy for all of you. I just want to ensure that everything is installed properly. So even I have a 8-core computer, I run microchip also got lots of problem. Okay, so if no questions, I think it's already over time. So thanks all of you. So enjoy your online sections, okay, throughout this semester. And I hope at least next time you switch on switch on the camera just for a while. So I don't even know how Xiang Li looks like. I don't even know how this handsome Ding Hui looks like. And some of you, I don't even recognize most of you actually, you know. So that is good to see who you are, okay? Because I'm not going to see you until end of this year, basically. So the Utah only reopen next year, you know. Okay. So okay. So see you guys and take a good care. Anything, just send me a message. Bye. Okay. See you. I stop the recording first.